The mathematical model representing the expected total energy generation will be presented by myself, Siva. My metric number is 19109236. Let's go. This part is to explain on the mathematical model of the biomass power generation. To find the biomass efficient transfer, first we need the value of the biomass in higher tropical level, then divided with the value biomass in lower tropical level. If we times with 100, we will get the percentage efficient transfer. Capacity. 1 million tons of agricultural waste is used to generate a 2.5 megawatt of electricity in a biomass power plant, enough to power approximately 2,600 homes, where it's equivalent to the one whole town. In Malaysia, can produce more than 2,400 megawatt of biomass and 410 megawatt of the biogas potentially. Rice husk is another important agriculture biomass resources in Malaysia. An example of the attractive energy potential is biomass power plant in the state of Perlis, which use rice husk as a main source of their fuel and generate 10 megawatt power to meet the requirement of 30,000 households. There are many techniques through which biomass can be converted to electrical power, such as combustion, pyrolysis, gasification, aerobic decomposition. At the end of this all method, different type of the fuel substance will be produced, and the fuel is used in the steam turbine to produce the electrical energy. Okay, let's see about the steam generation control system, where this equation is used to calculate the constant of the equation, or we can use to find the FP, which is saturated water of steam properties. First, the equation is F equals to Xm plus Knp. Fp is referred to the saturated water or steam property, equals to Xm, constant of the equation, plus with the Kn. Kn is the first definition of the saturated water, with definition of the steam pressure, times with the pressure, steam pressure. So we can find the saturated water. Moreover, we want to look on the turbine and generator. So this is the block diagram of the turbine control system, where there is consists of comparator, servo motor. That's another name which is we call a PIC controller. Next, the signal will transmit to the steam valve system. Later on, we will see about the calculation and derivation formula for the servo motor and the steam valve. I explain about the signal wire transfer and why we should calculate the servo motor and the value of the steam valve. First, the converter will send the speed signal to the servo motor. Servo motor will be determine how speed the motor will send the signal. In the steam valve system, the valve will determine how and direction the valve will open. Later on, the signal will transmit to the turbine. The turbine power will produce the electrical energy. Okay, let's look for the calculation. Now we want to look about the formula of the PIC controller equation, where du over dt equals to Gp. Gp refer to the gain factor of the PIC controller, times with the first differentiation order of Nt. Nt refer to the turbine speed divided by the dt, plus the Nt. Nt refer to the turbine speed minus with the turbine speed not divided by the time constant of the controller element. By this, you can find the value of the controller equation. Moreover, we want to look about the steam valve equation, where this will use a double second stage of the differentiation, plus with the natural frequency of the steam valve, plus with natural frequency of the steam valve system power, bracket with C1 steam valve coefficient minus with the steam valve coefficient not, we will get the steam valve value. Now we want to have a look on the turbine power equation, where the equation is the Pt equals to C1 P delta H. To find the Pt, which is we call turbine output power, which is the equation is equals to steam valve coefficient need to times with the turbine power output power and times with the overall enthalpy drop in the turbine. Thus, the total energy generation will be calculated from this turbine of output power.